of symmetry. And you cause a congruent reverse image of the shape with the exact length from the lines as the original.
Okay, and rotational symmetry is when you rotate a shape around a given point a certain number of degrees, creating a congruent image that is rotated around the point that number of degrees. Like so.
Translational symmetry is when you take a shape and slide it so that each point and line are an image that is the exact length away.
Part 2. So for 2A, for two Hauer points and their images related by each of these geometric transformations. A, reflection in line M. The point's image is on the opposite side of M and is the exact distance away from M as the original point.
Point 2. The image of the original point is rotated d degrees around point P and is still the same distance apart.
And part C.
Part C, you mean? Yeah,
Part C.
I forgot to do.
When you translate a shape, all of the points and lines are moved the same distance away at the same angle, so you have a congruent image a certain distance away.
No, how do we get that to go?
Okay. And part 3. How do reflections, rotations, and translations change the size and shape of line segments, angles, and or polygons, if at all?
They don't change the angles or lengths at all, because when you translate it across, you can see that both the angles and the lengths are exactly the same. Yay. Rotational. They do not change in rotational either, because when you rotate it, so I have to measure that one.
They are exactly the same.
They are the same angle, as you can see. And we can also measure these lengths to check, just to be sure. Hello. Alright, part 3. When you translate an object, you can see once again that all of the angles
are the same,
as well as the lengths.
So when you do all of these three things, they don't
You
change
can tell that
anything. Like,
if an object to be symmetrical has to not change any of these factors.